Well, chemistry's always been my main interest.
I've always wanted to be a dermatologist.
What I'd like to be is an astronaut, if that's possible.
I'm planning to go on to college, and I'd like to major in biochemistry.
I've always had a great interest for mathematics, and I've done well in it in school.
I'm interested in engineering.
I want to be an engineer.
I intend to be an engineer.
Engineer? What is an engineer?
The engineer. Who is he? What is he? Where did he come from? What does he do? Part scientist, part artist, part businessman. He seeks the useful. His impulse is to find something superior, something new. His field is broad. His field is specialized. You're a civil engineer. You design buildings, bridges, structures of all kinds. They stay up. We can depend on it. You're with the municipal sanitation department of a large metropolis. Your challenge? A big one. Meet constantly increasing water demands with a limited water supply. Your resources? Your knowledge, your talent, your imagination. You design a gigantic retention reservoir which prevents flooding. You then engineer a water storage tunnel 700 feet below the Earth's surface. It's 60 feet in diameter, 60 miles long. You design and develop sewage processing, which makes used water new again, pure enough for fishing, boating, swimming. Then you add a human touch. You design the reservoir so it can be used as a recreation area when it's not retaining overflow. You're an electrical engineer. You understand and deal with sound, heat, light, metals, and that ever-fascinating phenomena, electricity. You design communication systems that enable us to talk cross town. Over the continent or across an ocean. You take coal, water, nuclear energy, and plan equipment that generates the electric power that runs our industries, lights our homes. Or design advanced warning systems, standing 24-hour guard in winter wasteland, while at home we work, we sleep. You speak many languages, fluently. Electromagnetic theory, differential and integral calculus, Boolean algebra. You're a mechanical engineer in the aerospace field. Your responsibility is the flight control system for a spacecraft that is to land at a precisely designated spot on the moon. You coordinate all the parts into a whole. Star and sun sensors, attitude control jets, retro rockets, vernier engines, electronic amplifiers, hydraulic and pneumatic components. You work closely with the engineering specialists who design these elements. But the final decisions are yours. The final decision is yours. You've engineered a system that must decrease the spacecraft's velocity from 6,000 miles an hour to 3 miles per hour at a point 12 feet above a precisely designated landing spot. It must stand up under surface temperatures ranging from minus 250 to plus 250 degrees Fahrenheit. It must operate reliably in the hard vacuum of outer space, respond quickly and accurately to the commands of an earthbound control team. All of this to land a delicate payload of scientific instruments. Will you succeed? You put your reputation on the line so we may gain in ultimate knowledge, facts for the scientific world, clues to the origin of the solar system, perhaps even the start of an answer to the origin of life itself. The engineer, If you had to sum him up in a few words, you'd say his purpose is to apply scientific knowledge. No, make that knowledge of any kind to make our lives richer, safer, less burdensome. But the key word is knowledge. The engineer has to know much about many things. This is where an engineering education starts, in high school.
Today, I'd like to show you a practical application of that particular mathematical function. I'm using the pH concept of solutions in which the pH is equal to the log of the hydrogen.
Mathematics is one of the main tools of the engineer. You can't build a $20 million nuclear reactor and then hope it will work. But the function of a reactor can be approximated mathematically with a computer. Ability in mathematics is a fundamental requirement of the engineer.
Henry S. Ruth, Deputy Director of the President's Commission on Law Enforcement, stated in the Annals that organized crime acquires about twice as much income from its illegal operations.
A good command of language is important. An engineer who can't clearly explain his ideas and convince others is of little value, no matter how technically talented and creative he is. An engineer must be able to communicate. An engineer must learn the art of writing. He has to communicate by means of reports and memos. He may have to write sales proposals. He writes technical papers to pass on to others what he has developed.
Why should I consider a career in engineering?
When a student thinks in terms of engineering as a vocation and lines himself up with the personality characteristics necessary, one important item seems to stand out. If he is interested in the why of things, not the what, then I feel that he is tuned in to what engineering means. The why of communication with people, the why of a mechanical object, the why of the world around him. Not just what it does, but the why.
I'd like to tell you what kind of young people we'd like to have coming into our field. We'd like to have either fellows or girls who do well in math and science courses in high school, but also who are leaders and enjoy working with people, can communicate their ideas and can inspire a group to work together.
Did I consider a career in engineering? Would I qualify?
I want to be an engineer because I think it's a challenge to be given a problem and to try to find an answer to the problem in order to help people.
I'd like to be an engineer because I feel that engineering is such a diversified field that I would be able to pursue all my interests.
It will be a part of the future, and I want to be a part of the future.
All through high school, I've taken math and science courses, and I've done well enough, I think, that I could benefit by going into engineering in college. Engineering will not restrict me to any particular field. It is a good foundation for just about any field.
As long as I can remember, I've always had a special interest in the mechanical side of things. I used to like to take things apart and put them back together. I suppose this is basically why I chose engineering for a career.
Where do I find out more about engineering?
One of the things that has really given me a taste of engineering here at school is belonging to the Jets Club. By working on a project with other kids and taking trips to companies of interest in the area, I have really gotten a taste of engineering and really learned to enjoy it.
There are any number of sources of information relative to a career in engineering that would be available in a normal high school. Counseling office would be a first stop for a student interested in this area.
What courses can I take in high school to prepare for engineering?
In order to prepare for a career in engineering, I feel it is important for you to emphasize the areas of science and mathematics. We're speaking about the many different kinds of math, such as algebra, geometry, calculus, and the sciences, especially physical sciences. Physics would be the most prominent example.
What's it like in engineering school?
I'm a college senior, and I've just about completed the 4-year curriculum in electrical engineering. With regard to that curriculum, I'd say that the first 2 years have consisted of basic courses in physics, chemistry, math, and economics, and engineering science. And the last 2 years, I've finally gotten down to my electrical engineering electives, especially in the senior year.
I'm working on an engineering research project this quarter. We're studying the structure of polymers, which are the basis for many of the plastics today. We're using X-ray diffraction techniques to try and determine just what the polymers look like and how the molecules are arranged within the solid plastic.
Even though I am majoring in electrical engineering, I have found time in my schedule to fit in many liberal arts electives. I've taken courses like philosophy and English so I can broaden my base of education so when I go out into the world, I will be able to talk to people. Engineers don't have to spend all of their life with their nose in the books. It requires a fairly constant output, but there still is time for extracurricular activities. For instance, at this school, a third of the members of the marching band are in the Tech Institute. And most of this third continues through even up to the full 4 years of marching band. In addition, I've been in several stage productions, one of which I met my fiancée in.
What does an engineer do to help people?
There are many aspects of engineering which are responsive to the problems of society and to people in general. It's important when we look at engineering as a career to recognize that it's really very different from the hard sciences, in that engineers, by and large, feel an obligation to look at, analyze, and solve the problems of people and the problems of society.
I happen to be one of those people who think that engineering, in a sense, is one of the social sciences, because although our work is based on scientific advances and on technology, the goals of engineering are in the social area. That is, we're interested in improvement or the betterment of mankind.
For example, the young bioengineer may graduate and, with his bioengineering degree, go and work with a medical team in a hospital and help develop better heart pumps or better monitoring systems with various engineering computer devices to watch over patients undergoing operations.
In environmental health engineering, we are concerned with preserving and improving the quality of the environment. This includes both of our recreational areas in the water, the recreational area with regard to the use of land. It is also interested in maintaining and improving the quality of the air that we breathe.
What are my chances of getting through engineering school?
In my particular field, which is electrical engineering, there is no question that the curriculum is a tough one. However, it is in no sense impossible. And any high school student who has a real interest in physics and in mathematics, and who does reasonably well in these, is quite likely to succeed.
Well, actually, I think the first 2 years are the most difficult. During these 2 years, you take all your physics and chemistry, mechanics, and all your calculus. And believe me, it gets pretty rough at times, but if you stick it out, eventually you'll get into your specialty. And after that, it's all the way downhill, and it's enjoyable, and before you know it, you'll graduate.
What happens after graduation?
It depends upon what the engineering graduate is planning to do. Many of our students will go on into graduate school and will, if they're going to specialize in the technical fields of engineering, they probably need to do graduate work and work for a master's or a doctorate. Many of our students will go on to law school or go on and get an MBA degree. Many others are well prepared to go directly into industry and work in sales positions, on project teams and this sort of thing.
Immediately after I finish my schooling here, I plan to accept a job in California for an aircraft company. My first work will entail an analytical sort of work. It's analysis of test data and test performances.
When I first came here, I thought that I was interested in doing research in nuclear engineering. However, after a year and a half, I found that I was more interested in technical journalism. For this reason, I am pursuing an engineering education with the idea of getting a general background in all the fields of science and in as many engineering areas as possible. I hope eventually to be able to communicate the ideas of engineers to the general public.
And as I came here, I found different opportunities in the civil engineering department, especially in city planning, which I didn't know engineers worked in. And this interested me quite a bit, and I'm taking all my electives in this field. And then I also discovered that through my church, they have a Department of Urban Affairs, and they might be able to use someone with my background in city planning.
After I take my BS, I plan to go to graduate school because presently I don't feel qualified enough to take any challenging job. After I finish my MS, I plan to go back to my homeland Tanzania, where I can help my people.
The engineer. Who is he? What is he? What does he do in his workaday world?
I am now working on our EAX, electronic automatic exchange system, and I am developing testing procedures and production procedures for it.
At the end of this year, our company are opening a new plant at Huntsville, Alabama, to produce solely telephones. And as the chemical engineer down there, I will be responsible for the finishing department, which includes plating, painting, polish and deburr, heat treating, print and etch, and the chemical metallurgical laboratory. I will be spending approximately $1.5 million on this equipment.
For the past 2.5 years, I've worked in a specialized field of my industry. Just recently, my company decided to send me to a special school for technical education with the purpose of giving me a broad range of experience in a short amount of time. It's a 15-week school. We live on site, eat on site, and study here. The company pays all the expenses, and we think that it will be a good way to bring younger engineers up to a level of great proficiency in a short amount of time. It really bridges the gap between a college education and the practical industry of today.
I'm a year out of college. When I first came with the company, I spent 2 weeks in each one of our operating departments where I got an appreciation of what was going on in the company. The company then sent me back on a rotational program where I went back to these same departments and spent about 1.5 months in each one of the departments as a first-level supervisor. During that time, I was responsible for going in and running these jobs. At times, I might have women reporting to me, or maybe a large group of men. On other occasions, I would be working on a special project and have to come up with study results.
I'm a graduate electrical engineer, and I'm responsible for the administrative management of a professional consulting organization in the Midwest. Our job is to help our clients through an approach to problem solution which includes many areas of expertise, of which engineering is a very important one. We combine the talents of behavioral scientists and engineers to bring about a total problem solution. It means that our engineers here have learned that the engineering profession has a very significant role to play far beyond the limits of engineering itself. For example, we've just completed a very successful program for a major bakery on the East Coast, which, through the application of better distribution methods designed by our engineers, better marketing methods by our marketing analysts, and better selling methods designed by our behavioral scientists, has vastly improved their total marketing and selling and profitable operation.
What kind of future is there for an engineer?
My position is that of Vice President in charge of engineering, power plant construction, and research for a major utility company in this country. Our business is that of generating, transmitting, and distributing electrical energy to some 2,200,000 customers in our service area. In our company, we have some 900 engineers. Now, about 2/3 of these are engaged in highly technical work that one really couldn't use other than a technically trained man or one with an engineering education. The remaining 1/3 are in sales or administrative or higher level executive jobs where conceivably one could use people other than those with a technical background. However, the unique training of the engineer, his disciplined mind, his orderly approach to problems makes him exceptionally well qualified for these other positions.
Advancement in our company is on the basis of ability. We think that our job as management is to provide the opportunities to learn and the opportunities to develop professionally.
We look to the young engineer to take advantage of those opportunities and to work at his professional development. Where a young man goes in our company depends upon his ability, depends upon the effort he applies in his professional development, and depends upon his personal goals as to where he would like to go.
You're an engineer. You've got your work cut out for you. The pattern is set by things and people. In 10 years, there are going to be 20 million more Americans. That breaks down to 11 million more school kids, 700,000 new classrooms with teachers to match. You've got to engineer schools and homes and factories and office buildings, bridges. You're going to have to build roads, overpasses, and parking places for 40 million more cars, and that's just the hardware. You're going to have to contribute to a national muscle that will stand up and knock down social problems that just won't quit. Dropouts, drug addiction, community unrest, crime, poverty. You're going to invent more efficient methods, more effective instruments, and you're going to use them in new and imaginative ways. You're going to create what has never been: adequate low-cost housing for the poor, the means of extracting food and other natural resources from the ocean depths. You're going to control climates, make air and water pollution a thing of the past. You're going to engineer pocket telephones, picture phones. You're going to draw upon your curiosity, your perseverance, and your hard-won education. You're going to share these things with sophisticated machines, not to find a satisfactory way, or even a better way, but the best way for us. Your reward? Perhaps the greatest of all. The feeling that what you learned was worth learning, and what you did was worth doing.